Hello, my name is Laura Dietz, and I'm a postdoc at the University of Massachusetts working with natural language processing, information retrieval, graphic models, and so on. Today we'll give a talk about entity linking, which is interesting from my perspective because it's just in the intersection of all the different things I'm interested in. If you don't have my picture on the video live feed, here's a picture of me. You have my email down here. Whenever you have any questions about the talk or after the talk, I'm always happy to answer any kind of email. So what is this problem that we're trying to tackle when we're talking about entity linking? So we are in the situation where we are given a document or like a text fragment, and inside this document there's like one little piece of text selected, which is what we call an entity mention. So we hope that this one refers to an entity. And in entity linking, we are also given a knowledge base, and the task is to indicate which entity this string represents. So if the string represents an entity in the knowledge base, we want to return this one to the user. If we don't have any entity in the knowledge base that are represented by the string, we want to return nil, which means none of the entities in our knowledge base represent the string. For the rest of the talk, I will talk about Wikipedia as a knowledge base. I know that you have heard of linked open data in the past hours. So actually any kind of like knowledge base of linked open data or Freebase and so on and so forth can be turned into something like that would be the input into the algorithms I will talk about in the next half hour. So here's an example query. Here's some text on Northern Ireland talking about a time in 1921 where there was some contentions between Protestants, also called Unionists, and Catholics. And there was a prime minister, actually the first prime minister of Northern Ireland, whose name is Sir James Craig, and he described the state as having a Protestant parliament for the Protestant people. So in the snippet, let's say we select the string Northern Ireland. So you want to know which entity in our knowledge base, which in this case is Wikipedia, is referring to Northern Ireland. And what you want to see is this Wikipedia article on the country Northern Ireland. So Northern Ireland is a rather easy entity to disambiguate because when we talk about Northern Ireland, we almost always mean the country Northern Ireland with it. But how about if we select a different string in this text, for instance, James Craig? And let's say we just run this as a query in Google. Then we suddenly get a result about a James Craig who is an American actor who starred in B movies in the late 1930s. And you wonder, what does this person has to do with Northern Ireland? And the answer is nothing. We just found the wrong James Craig. It's not the James Craig that this text is talking about. It's a different James Craig. The true James Craig was actually, according to like Google's ranking, on rank number 2. Here, the one that's marked in the picture, also referred to as James Craig, the first Viscount Craigavon. So it's a near miss, and we would like to fix the situation. So what this example should tell you that entity linking is not an easy problem, and but we will talk about different algorithms who actually would get it right in this example. So this talk is to be understood as a method of cooking ingredients for entity linking solutions, and modern entity linking systems are actually a mix of all these 5 algorithms I will talk in the rest of the talk. I will also give you like some experimental results, so you see in numbers how these methods work with respect to each other, and I will also conclude with some online demos and to see how they perform in entity linking. For the talk, there are 2 very central concepts or challenges. First one is ambiguity, which refers to the fact that when I talk about one particular entity by its name, the way they refer to it might also refer to other entities. So we have some ambiguity in our language about which entity we are referring to. The other concept, or the other challenge, is what we call a synonym. It means that one entity usually goes by a variety of different names. So these 2 challenges together actually make entity linking a hard problem. So coming back to our example text here on Northern Ireland, where the query what we call the string here, it's what we call the query mention, which we want to have aligned to our knowledge base. Most entity linking system starts with like a first step that's some kind of document analysis, where we process the text with some low-level NLP tools. For instance, we apply within Docker reference to get other pieces of text, like here indicated by empty rectangles, that would also refer to the same entity. And we can apply some named entity recognition to find just other entity mentions in the text. So we know that there's like text spans that are very likely to refer to an entity, but we don't know which one it refers to yet. So for the rest of the talk, I'm going to have the symbol notation of the little black rectangle box being the query mention, the mention that we want to disambiguate, and empty black boxes refer to name variants, and circles or ovals are referring to contextual entity mentions, where we may also have the sentences usually indicated as a whiskered line. Let's start with our very first method. It's kind of like a simple method, but it actually gets you very far along the way. It's usually referred to as the popularity method, and it works by having multiple steps. In step 1, we build a dictionary of names for each entity in our knowledge base. And in step 2, that's where our query mention comes into play. We inspect all entities in our knowledge base that have this query mention as a name variant, either as like the canonical name, or as like other names that we have identified for this entity. So it might be that, especially like for ambiguous mentions, that we have several entities for which the criterion in step number 2 actually holds. So in this case, we choose the most popular one. And here it's like the most popular through is kind of like measured as in popularity by inlinks. So how do we go about building this dictionary of names? So in our scenario of using Wikipedia as a knowledge base, we can take the Wikipedia articles as representative forms of each of the entities. Like here we have the articles on James Craig, the first Viscount Craigavon. We have the article on Northern Ireland and unionism in Ireland. So we can look at the different hyperlink structures that point through other articles within Wikipedia. For instance, this link down here gives us actually two kinds of information. First of all, it will tell us that this entity with the canonical name James Craig, 1st Viscount Craigavon, which is a little bit lengthy, and it's very unlikely that people really refer to him in normal written text, that for this entity we have an alternative name, which is Sir James Craig. The other thing that we learned from this link is that this entity is related to an entity that's called unionism in Ireland. So from the raw Wikipedia input, we can extract like some abstract entity notion, where we assume that every article represents one entity, and this entity has a list of different names and is connected to other entities with different titles. So this can also be generated from any other knowledge base. For instance, if you have RDF triples, you would assume that every subject is an entity. And then maybe you have a particular relation that refers to other name variants for this entity. And you have like relationships that connect this entity to other entities via some predicate. So to recap the first method, in the step 1, we built a dictionary of names for each entity, and I just explained how we can do that. And in step 2, we now go through all the different abstract entity representations and check and select all entities where the query mention occurs as a name variant. And then in step 3, we choose the entity with the most inlinks through this name. That means we look at hyperlinks that have the query mention as anchor text, and among those, we just check which of the entities are hit most often by those hyperlinks. So this method works very well for popular entities, such as Northern Ireland, or in cases where we only are interested in entities that are just like the most important entities in the world. This fails for entities with confusable names, for instance, That often happens for person names like James Craig. There are also certain towns that have just a very popular name like Springfield. Like literally every state in the United States has a town called Springfield. Or for concepts like Jaguar that may refer to both the car and the animal and so on. Let's look at other methods. So here we have method number 2. We look at one that actually leverages machine learning. So we want to machine learn a similarity between a string and an entity. So in step 1, we collect different similarity features of the query mention and the entities. And in step 2, we apply machine learning to learn a weighting of these features given some training data. So here we can either use a classification SVM, or we can use a learning to rank SVM, or any other kind of discriminated classification or re-ranking algorithm. So once we have trained the machine learning on these features, the machine learning feature weights, in step 3, we then consider the query mention, and we have the pool of entities that we, for instance, select by the ones that have this name as a name variant. And then among those, we just pick the one that has like the highest score under the similarity metrics that we just learned in step number 2. So what kind of similarity features do people use? So here we have 2 entities. This is James Craig, the American actor, and here we have the Northern Irish Prime Minister, James Craig. And for instance, in Wikipedia, there are different kinds of names that have like a different reliability. For instance, we have the Wikipedia title, which is usually like a lengthy name, or like has like some weird parentheticals in the name that is just not very likely to occur exactly this way in text. But if we know that we have an exact title match, that's clearly like a very strong indicator that this was actually the entity that we were looking for. And there are also anchor texts, like what we already explored in the popularity method, and we have disambiguation pages. So the names in the disambiguation are just like very general names, but it usually gives like a strong indicator that this is like a very common name that an entity of this kind can be referred to. However, it's just not very good for disambiguation. Maybe it's a misnomer here. We can also align it with other knowledge bases. For instance, we can look at the Freebase name. Here we have Lord Craigavon, or Yago, or other names that we can mine with natural language processing. So from these different names that we can identify, we can turn each of them into a different feature. For instance, we can, in our feature vector, we can have the first entry be a 1 if this query mention here is an exact match in the title, which is no in both of these entities cases. We can ask, is it a disambiguation match? That's like the other end, which will be true for both of these entities. We can also look at what are the number of inlinks through this name. This is exactly the feature, like here we have as a feature what the popularity method used as the main ingredient to the algorithm. So in a way, method number 2 encompasses method number 1. We can also incorporate like approximate matches like TF-IDF similarity or Jaccard similarity or the dice score and so on and so forth. So once we've built feature vectors for the query and each of the candidate entities, we can then apply machine learning. So we train the machine learning by having known queries with known candidate entities, with known true entities, and we then learn feature weights to maximize situations where the true entity ends up being on rank 1. And then during the prediction case where we have our new query mention that we haven't seen before, we then compute the feature vectors and we just apply the machine learning similarity metric here. So this will give like a new ranking among the candidate entities, for instance, like on rank 1, 2, and 3. And then we can either just return whatever entity ends up on rank 1, or we can apply the nil classification on top of it, where the goal is to figure out whether this entity is close enough, it's similar enough to the query mention to be a good match, or whether we'd rather be on the safe side and say we don't know any entity in our knowledge base that refers to this query. And of course, we can use other features in this feature vector, not just name variants, but also we can leverage the document terms and some of the link structure and so on and so forth. So the advantage of this method is that we combine different indicators of similarity that are reliable to different degrees, and the machine learning method will even make use of the weaker indicators. We also have the option to predict nils, or I don't know this entity in my knowledge base, which is a very useful thing in practice. This method can further be extended to include name variants that we find in the text with coreference tools, although I didn't talk about this here. It would just be like more entries in the feature vector. The downside is that this method requires a selection of a pool of candidates, which can be large if the name is very general. And for instance, imagine like all entities that are referred to as John Smith. So now we may have like hundreds of thousands of entities for which we have to generate feature vectors in order to make a decision which of the ones is the best one. Also, this method still fails on our James Craig example because the wrong James has just way more anchor text matches, and the machine learning method probably picked up that these anchor text methods, or the popularity feature for method number 1, is a very useful one, and then it would just lead to the wrong James Craig. So it seems like the problem is that we only look at the name and we don't really leverage the context in which the query mention contains in. So here's a very simple method. So how about we first identify the text and the entities that surround the query mention, and then we comprise a big search query containing all of it and issue it against Google. So here's our example fragment. So here we have the query mention, and we have different name variants that we find with the coreference algorithm. And we have other neighboring entities like Northern Ireland and Catholics, and while we already added, we can just like throw all the terms here in the sentence also in the query. Now we search for James Craig, the name variants, the neighbors, and the sentence. And yes, it works. It puts the right James Craig, the first Viscount Craigavon, on the top of the ranking. So this method, although it's kind of like brain dead, it clearly works for James Craig. And it shows like the use of information retrieval in this field for entity linking. However, it's problematic when neighbors are ambiguous. For instance, in the string, Lisa witnessed the shooting at Springfield High School, it's unclear which Lisa and which Springfield we are referring to. It's also problematic when neighbors don't provide enough disambiguation power. For example, there are all other James Craigs of Ireland which are just less popular, and we have no way of actually reaching them, just by having Northern Ireland in the context. So here is just like a section, like a little bit of entries on the James Craig disambiguation page, and the blue boxes refer to James Craig entities that actually are Irish or related to Ireland. And we see that we have Irish painters, we have a loyalist, actually from the other side of the party, we have physicians and other politicians in this list. So whenever we have James Craig in Northern Ireland, any of these James Craigs would be fine matches. And it just happened to be that the first Viscount Craigavon, because he was the prime minister, and actually the first prime minister is like a very often cited entity. So let's consider method number 4. It's a more elaborate method that makes use of graphical models. We call them the joint assignment models. So in step number 1, we identify all entity mentioned in the text. That's like as we had before. We have the query mentioned James Craig, and then like other name variants and other contextual entity mentions. And then in step 2, for each of these mentions, we retrieve the pool of candidates. These are like all entities that contain the respective mention in one of the name variants. And in step 3, we select the entity of the target pool that maximizes the following equation. I'll talk about the equation in a little bit, but conceptually what it means is that we want to select the right entity that does not just have a high similarity to the query mention, but we want one that's also compatible with other entities that have a high similarity to the contextual neighboring entity mentions. So it's like asking, is it likely that two entities are mentioned within the context of the same, within context of each other? So here's the how it would look like from the perspective of our running example on James Craig. So we have James Craig, the query mention. We have contextual entities, Northern Ireland and Catholics. So for each of those, we retrieve a pool of candidates. Here we have our two James Craigs. There are many more of them, but for simplicity, I only list the two here. Northern Ireland is a not very ambiguous entity mentioned, so maybe we only have one Northern Ireland here in the candidate. But for Catholics, we have like a very popular, the Roman Catholic Church, and maybe a little bit less popular, the American Catholic Church. But just from the word Catholics, we don't know which of the two are like more appropriate. So now we inspect different settings that we can choose for entities that refer to each of these different mentions. For instance, that means we choose from every line, we choose one of the entities. For instance, we choose Northern Ireland, the First Viscount Craigavon, and the Roman Catholic Church. So now we need to like have a way of scoring whether this is a good assignment or not. So here we use, this is where the bigger equation comes into play. So the score includes, as a product, the similarity between the query mentioned James Craig and this entity here as before. So this is exactly what we used in method number 2. In addition, it also includes for every neighboring entity mentioned, for instance, Northern Ireland here, the similarity measure between Northern Ireland as a query string and this entity over here. Same for Catholic and the Roman Catholic Church. And in addition, we have these two red factors over here that just measure how likely it is to see an entity Northern Ireland linked in mentioned in the context of James Craig, the First Viscount Craigavon. We may have to look through all different selections. For instance, here is a not so good selection where we choose James Craig, the American actor, which might be very compatible to the American Catholic Church, sure, why not? But it's just very surprising if the American actor is mentioned in the context of Northern Ireland. That's just like way less likely than having the other James Craig. So in this case, Northern Ireland is a disambiguating factor that points to the First Viscount Craigavon versus the misleading and mentioned entity, the American actor. So we have to learn similarities because in order to resolve the product, we need to have one scalar value, and maybe we have different features that have different indication here. So as in method number 2, we learn the feature-based similarity, but we have two kinds of similarities. The first one is the similarity between mentions and entities, which is what we already learned in method number 2. And the same similarity is used for both contextual neighbors as well as the query mention. In addition, we have to learn an entity-to-entity similarity, which should tell us how likely it is to have these two entities be mentioned in the same context. And here we can use different kinds of indicators. For instance, a mutual link between these two Wikipedia articles is a very strong indicator. If they have the same category, that's another indicator. If we are in an RDF triple store, having relations between these two entities is just a strong indicator. So to recap, in joint assignment model, in the first step, we identify all entity mentioned in the text, like over here. In step 2, for each of these mentions, we retrieve candidates over here. And then in step 3, we iterate through all possible combinations and select the target entity over here that maximizes the joint probability, which is just like the product between these factors, and the compatibility factor. So it's kind of like obvious that this may get a little bit expensive if we have many mentions in the text, and for some of these mentions we have like high ambiguity, which means that we get a pool of entity that's really, really large. So the advantage of the method is that it can actually resolve mutual uncertainty. That means if we have two entities that by themselves could be confused with other entities, but maybe the fact that they're mentioned in the context will help us to actually resolve the ambiguity. A downside, it requires a pool of candidates, and here we have to trade off runtime versus recall, because it can turn into a very expensive inference problem if we have many mentions and deep pools. It may also still fail on the less popular James Craigs or when the context does not resolve ambiguities. I will now talk about the last method, method number 5, which we call the joint retrieval model. in step number 1, we identify all entity mentions in the text, as in the previous method over here. Then for each of the query mentions only, we issue a search query including the query string, neighboring mentions, and the sentence rating each ingredient differently. And here the idea is that we want to have a structured matching of text to KB. So this is kind of like a similar approach than what I was talking about in method number 3. But here the difference is that we want to have a different rating and we actually apply machine learning. So as a recap, when I was building up this abstract entity representation, we were looking at the different Wikipedia articles where each of the articles represents a logical entity. And I was talking that from this link down here, we're first of all getting Sir James Craig as another name alternative, but we also can take away that this entity is related to an entity called Unionism in Ireland, and that this will end up actually being part of the abstract entity representation. So we are going to leverage this in the scoring for method number 5. Coming back to the Northern Ireland example, we are not retrieving any candidates for any of the other contextual mentions. We are just, because we only want to disambiguate this query mention over here. And we score it by multiplying the name similarity between James Craig and this entity with compatibility factors that are based on the neighbor mention with this entity. For instance, here we have a string Northern Ireland, and we see that Northern Ireland is also mentioned as one of the inlinks into this entity. So we can, from here, that's really like a strong indicator that this is a good assignment, and that the actor is not a good match here. So that's an obvious connection between method number 4 and method number 5. Method number 4, we have explicit pools of entities, and we treat them as like an explicit inference problem. But that's also where the computational complexity comes into play, because we have to try out all these different entities to score them mutually. Method number 5, we kind of like integrate over these latent entities in the context, the entities that we don't really care about just for the sake of disambiguating this particular mention over here. And it falls down to be like a much simpler equation that's similar. It's just like these two factors over here, from the string to the neighboring entity, and the neighboring entity to the target entity, is just summarized as one factor. The advantage is that this is such an easy equation compared to that one that it cannot just be solved analytically, but it can be even solved with a standard search engine. So here the idea is that we have all the different mentions in the text, and we turn them into one IR query that we issue against a special search index, where the search index contains our abstract entity representations. And this can allow us to implement features like the neighbor occurs in the entity's text, and the neighbor is a title of the inlinks, the outlinks, or a list of mutual links, or the same context links, just with straight up information retrieval. So here's how we do that. So we start with the abstract entity representation, and we turn it into kind of like a generated text document that has different sections. So the first section is where the Wikipedia title goes into, because it's just like a very canonical name, although it's often very rare, but it has like really high weight. And then we have a different section, or potentially multiple sections, that contain all the other name variants. And then we have another section that contains the inlinks, the outlinks, and the mutual links. And while we already added, we can also throw in the whole full text of the Wikipedia article. So this abstract document here, we just submit that to the indexing process of any search engine. So you can, for instance, use like the popular search engine Lucene. In my lab, we develop our own search engines and for like research purposes. So we were using Galago in our experiments. So now we have a search index that's fielded, and we can do field retrieval over it. So in order to capture the entities, we now have the query mention and the neighboring mention Northern Ireland here. And this is the document that we just generated for James Craig. And from this document here and the contextual mention Northern Ireland, we can compute a feature vector asking, does this neighbor occur in the full text article of the Wikipedia? Or does it occur in the in-links or in the outlinks title or in the mutual links? Or maybe is this an approximate match? We can also include like TF-IDF similarity score, which is usually whatever is supported by your search engine. So we can use machine learning to learn these feature weights, for instance with the learning to rank method, and that will give us scores for the neighbor mention to entity. But often we can also take these weights and embed them in the search engine and just let the search engine carry out this the feature weighting. That will of course require that we first have these weights learned, what usually happens outside of the search engine. So we combine this with the query mention to entity features that we had before, like title match, disambiguation match, and so on and so forth. We also learn machine learning weights for these different for different entries, and we can also embed them into the search engine. So to cap up, in method number 5, the joint retrieval model, the idea is to turn the query mention and the context into a weighted IR query and run that against the wiki, like an index that contains our abstract entity representations. And this actually has the intuition of a structured matching where the name variants of the query mention should be matched against the names dictionary, and the contextual entities should be matched against the inlinks, outlinks, and the full text, or maybe there are some weaker indicators here as well. And at the end, the search engine would automatically select for us the entity that maximizes this equation here. We can also combine that with another layer on top, for instance with method number 2 or method number 4. The advantage is this method is similar to the joint assignment model. It captured the same spirit, but it's a lot cheaper. It does not require pools because we optimize over the whole knowledge base, because we do it with the IR entity index. Another advantage that it can be combined with machine learning, such as method number 2 to improve precision. We can also put another layer of method number 4 on top of that, with the advantage being that we use method number 5 as a pool generating method. So you have like much smaller pools that have a better chance of actually containing the right entity in it. Disadvantage that it fails when the context is misleading. So here's, for instance, a really difficult example, just in case that you thought that the entity linking problem is solved by now. So if you all remember the TV series Lost that was aired on American television just a few years ago. So it was shot by the American Broadcasting Company. And here's a short text fragment that talks about that. It goes, ABC shot Lost in Australia. So, of course, the true entity American Broadcasting Company is here represented by its acronym ABC. But there's another entity that also had the same acronym match. It's called Australian Broadcasting Corporation. And because we have Australia in the context, and there's not even like any question of ambiguity with Australia, but this is just like such a strong indicator that points towards this entity that we will always predict the wrong entity here. So in another paper, we described an approach to treat this by identifying misleading neighbors, and it turns into a variant of method number 5, but I'm not going to talk about this here. If you have any question about this, send me an email. So here's some experimental setup to give you in numbers how the different methods perform with respect to each other. So this is based on data from TechKBP Entity Linking Task. TechKBP stands for Text Analysis Conference Knowledge Base Population, where these charts, which was hosted along like the last 5 years, so here I have data from 4 years. These charts are to be read in, if we are like at rank 1, in how many cases would we have the true entity on rank number 1, where if we consider the top 5 ranks, in how many cases would we have the true entity among the top 5 ranks. So here we look at different methods. One only looks at the query, which is essentially the method number 1, the popularity method. And we see that it used to actually work rather well in earlier years, but as the organizers of the TechKBP challenge got together and thought, oh, we have to make this problem harder and harder, the method actually did not perform well. And maybe you can say that this test data was engineered so that the simple method fails, to show which of the methods actually can deal with like more complicated situations. The bold line here is actually a variant of method number 5 with kind of like a treatment for misleading context, like the joint retrieval model. And we see that this works quite a lot better than just doing the popularity measure. If you combine method number 5 with method number 2, that means the joint retrieval model together with like a machine learning on just the name similarity, we get an even better performance over here. So here's a list of references if you want to read up on these different methods. So it's a little bit hard to actually tease apart who invented which of these methods, because modern anti-linking system contains a whole bunch of those. But I think these are good starting pointers, and I also have a list of like more reading material down here. So here's a list of open source toolkits if you want to play around with entity linking methods. And here's a list of several online demos. And in the following, I work through each of these demos and see how they will perform on the James Craig example. So here, for instance, is the demo from UIUC called Wikifier. And we see that here James Craig is actually points to the right James Craig. Unfortunately, you can't really see that here, but you can see that Baronet Viscount member constituency should tell you that, okay, that system actually got the right James Craig. Same thing for the TagMe, which also was able to resolve to the right James Craig. And here is a demo from AIDA. This is the method that uses the prior, the similarity, and the coherence measure, and it also finds the right James Craig here. I like the AIDA demo because they allow to play with different extension of the model. So for instance, if you only look at the prior, we see that this method would not have been able to like refer James Craig to the first Viscount Craigavon, but it's the same mistake that Google also did when we only gave it the string James Craig. So obviously that example was actually too easy for most modern algorithms. So here's another example. I got it from the Wikipedia page on a reporter called Lisa Fletcher. And here's one string, and I took that string and I just disambiguated she to Lisa to see whether the entity linking method would find the right Lisa over here. And it turns out that all of these different demos actually refer to Lisa Simpson instead of Lisa Fletcher, which is just like a sure sign that somehow popularity, and Lisa Simpson is just way more popular than Lisa Fletcher, is still like a very strong indicator and makes many of these methods work, or in this case fail. Here's actually, just for comparison, I took the same text and I ran it through a normal search engine, in this case DuckDuckGo, and actually found the right Lisa on the top rank. So I hope I could convince you that entity linking is an interesting problem. I also want to mention that it's really not a solved problem. And I would hope that maybe you have your own ideas, and I want to encourage you to participate in some of the ongoing challenges to measure your entity linking strength with other researchers in the field. For instance, there's upcoming the TechKBP entity linking task in 2014. There's also at the SIGIR conference, there's going to be a workshop that hosts the challenge like on entity recognition and disambiguation, which is just another name for entity linking. There's also planned an INEX 2014 workshop challenge, and if you watch for the tweet contextualization track, that's essentially entity linking on tweets from Twitter. So if you have any more questions, so I'm now reaching the end of my talk. If you have any questions, feel free to send me an email. I will also put slides and a video of this talk online on my webpage over here. And I'm hope to take some more questions right now.